Okay, the team, I just opened your model and just take a spot looks. So plan, this month. Okay. All right. So I don't know which floor you're talking about where it has an issue. I will just take a look at it and just elevations. All right. So what you first you need to know that you should clearly notice this is the composite floor framing design, right? So this is first you need to start with the composite beam pro framing design. You need to use composite beam. And then let's see, low combinations, okay, strength. So this is seems correct. So I will just run only just one floor. I selected. You don't want to design entire floor. Since you designed the typical floor, so this is the size and the size of the beam and girder, right? And with the number of stud and camber. So you see this is the one typical design for composite typical floors. So you need to include and address and include all the calculation. Show this as part of design. You need to show like this and the output together, right? So okay, so since okay, so I'm gonna move up to 21st floor. You may have our legal truss. Okay, right there. So this case is the composite beam is, I think, should in this floor, what you need to do, you need to design and the member and all the member size should be okay with the composite beam. But this is our legal location. We'll check it out. Elevation section 2 and 4, right? So here, this beam is part of truss. We don't count on as a composite beam. And this is we need to run with a steel design. Okay, let's see. Section elevation 2 and see what you have here. So, for example, like this, I'm gonna select this and steel design, and same as the composite beam design, you need to select. Okay, something is not right. This is because of this steel beam sections design, you need to okay recreate the okay. Like this is yes, still maybe you can set it up. This is steel beam framing. Seems like you have it. Hold on, let me double check what you have. So what is this? Spomposdello. Okay, Spomposdello. Okay, this is a window. Okay, so. So this one is Delos, Pampas Dello, and Libra. Okay, so this is still frame design or combination. So strength, what's going on here? This is not right. Okay, something is screwed up. So, okay, so I'll de- delete all the low combination for steel. Instead, I'm gonna recreate it. Steel frame design. So let's see. Okay, that load. Okay, so this is all the steel load combination, right? Load combination for steel member design. So let's see here, steel frame load combination. Okay, so this is composite one, should not be here. So this is strength section load combination. You should use all the steel 1 to 14 and deflection, steel 1 and 2. Okay, so this is load combination you're gonna use. So this is part of truss, right? I told you. First of all, you size this, but this is not composite beam. This is truss, so you need to assign and define as a steel frame design. And then let's see, select and test from the design. All right, so this one, the 14, the 13, this one's still okay, but I use this is also same as this size because this is really truss. So I prefer to, because also we need a huge connection design, connection here, there. So typically I'll treat this as top chord member and diagonal. So, okay, so now what I think what you see here, so something's right. This is not W30 by 90. This is column, so it should part of this W14 or 730. So I think that's why first two things I think you have to understand, right? This you mistakenly, okay, you select and assign the W30 by 90. Should not be W30. This is W14 series. So I think when you do, you need to change the sizes, okay? And the second one, let me double check what you did. I think something if you have something wrong answer, obviously most likely you're the one you make a mistake. Here, see this W30 by 90 is not the column sections. So I'll choose W14 by 730. Okay, and also at the top core, maybe I'll choose some randomly, but uh, for now, for simplicity, 14 by 500, I will use it, right? And there is something we need to do it as well. Because this is too long, we may have to separate this at the middle. We can either break it or we may have to assign some embrace lengths of parameters so that this beam is not just spanning from all the way up to here. Even though one member side, this really one member spanning here, so there is a floor here, so this bracing should be braced by X and Y, both directions, strong axis and weak axis. So we'll get into that, right? Okay, okay, go back to elevation 2. Okay, okay, elevation 2. Okay. Hmm. I'm gonna assign 14 by 1 to 5 today. Do we use a 500, 550, 500, 500, 500, 500, 500, and 730. This one, 730, 730, 730. Okay, go back to level elevation 4 again. 730, 500, 500, 500, 730. Okay, so it seems like this is the one you probably may mistakenly assign the W30 by 90 to the column. So I'm going to run the model and see. Okay, so this is elevation 4. I'm going to only for now, I'm going to run the still for selected member. Oh, so this one still don't recognize it as still. So let me change this. And override still member. and then we run it. All right. So there's something. Okay. Oh, or maybe let's check the moment list here. Okay, moment list here, there. All right, since this is some the member you draw from top and bottom, right, as a one member, but physically it's a brace at the level two. So either you can break it or you can assign the uh, umbrella length factor. You want to break it? Let's say break it. So go to edit, define, and break it. So I break it. And this case is this one diagonal member should be continuous, not separated. So this guy, I'll make the beam is framing to the diagonal. So like that. So this is continuous one single member, but this beam is framing to this W 14. Okay, and elevation 2 again, same thing. I'm gonna divide. Okay, I'm gonna assign over the list. Okay, all right. So let's run that one more time and see. Okay, so I'm gonna select this, go still and run it. Okay, this still bending 0.9. So bending, I don't know why we have this significant bending moment here. So this diagonal is still not enough. Mm, oh, oh, we have this condition, that's why. Oh, we have this condition as well. The beam. Because we have an interior column. It's, yeah, basically, this is not the good way to do this. Okay, let me just prepare it. Oh boy. Okay, it's this diagonal. Yeah, typically we don't have interior bracing. Yeah, this diagonal maybe not good enough. Let's see. Instead of instead of this diagonal is passing through this column, I think we better just change this profile of truss. So instead, because we need all the legal truss, it should be concentric. So here we need to do this way because you have an interior column. I'll make this truss move like this and the bishop four. Okay, since the case, I need to fix this guy. This one's okay. Fine. Mm, okay. Mm, so that's that. What's happening here? Okay, join here. Join there. Okay, so I'm gonna make moment analysis. So super supported beam. So this is continuous member, right? I have only moment analysis here there. I'm gonna make this one. Okay, divide this. Okay, let's see. Okay, one member because the moment analysis at here there, right? Doesn't mean this is one single continuous member. Okay, so this is correct. Oh, elevation 2. Here, I'll fix it. Choice. Then KGI. And this one. So moment less. This one somehow break it. Okay. All right, seems like everything is ready. Let's run it. Okay, let's select, go to design, run it. Okay, now this side is okay. We have a quite significant compression here. May need a big sections here, there, right? Okay, let's see what row combinations creating. Yes, it's about 17% exceeded. So let's check it. Roll the combination 3. Roll the combination 3. All embrace length K effective length factor all 1. Embrace length factor is 1. So here, right, your maximum forces and capacity, you see the compression is exceeded your capacity. So we need a bigger section a little bit. Do we use so low combination 3? That's 3. So we have this cases. All right, there is some still issue since this model we didn't have the so we use construction sequence mode. No, we didn't we didn't use a construction sequence load, especially dead load. So when you see the dead load case, I think I explained that axial force. What you see is coming the gravity loading coming down, right? See the reduce due to the self-fed gravity load, right? You see this? I explained that. So minus 1298 is somehow pulled back by this the diagonal actually dump the loading. So this should not be the happen. And otherwise, if you using this model, you under design this column below this outlet truss. So we need to use some construction sequence analysis with some delay joint approaches. The so previous video I explained that what you need to do is you need to set up some the construction sequence of that loader. Okay, so I'm gonna no, actually I'll keep doing it. All right, so let's unlock what we need to do. First of all, this diagonal obligate truss, I'm gonna select and assign the group. Assign the assign object group. So obligate. So I'll assign this diagonal. So this diagonal should, uh, yeah, the group obligate, right? So what does it mean? I just grouped it. Select group, obligate, select, right click, select only member. You'll see only obligate choices assigned as the obligate group. All right, so now since we have some issue only because the building is constructed at a floor by floor, so all the loading has to be self-weight loading should be gradually assigned as the construction goes up, right? So here, auto construction sequence analysis, how if we're gonna use it and replace the current dead load with, uh, let me see, can we do it SDL as well? Okay. Um, So that's something we need to make sure that our load combination, which is easy. So that load, we have to use SDF. For now, let's use that load only. And combine the number of storage construction for time saving. Assume two. But during the construction, exclude the outrigger construction, and this means is it has gonna build every floor. I'll show you the video. So construction is going at every two floors in the analysis, and the diagonal members because we exclude that the outrigger truss diagonals from this construction sequence. When every model is constructed up to the top level, we assume that our legal diagonal will be added. So, okay. So this dead load I'm gonna use replace this order sequence dead load will replace the previous dead load cases. All right. So here, let me see. So they didn't replace yet. So let me delete it and let's double check order sequence analysis. So this is downloads or sequence construction sequence download. So we're gonna use this that load still frame design. Let's see what do we have here. So here previous download is replaced by this order sequence download, right? So okay, so we are ready and then let's run it. All right, so Let's run it and design check again. Okay, so what you see, a pretty color, and go to design. Let's turn on the and stress ratio. So what we did, the two things, I think this is column size changes. Okay. So first of all, we initial diagonal bracing is spanning from here to here, which means this diagonal somehow the hit with the interior column, which actually generates the bending moment. So I think we typically we don't do it. So what does it mean? And outrigger truss, this truss should be concentric, right? We should not frame it into the middle of the column. So I reconfigure the diagonal, right? So that is one thing. And also we did the construction uh, sequence analysis. So first, due to the deadload, let's check it out. So you see that if you run regular deadload cases, which means all the model is constructed and then that load will be simultaneously assigned. So that means due to the our diagonal members is right there, is pick up some gravity load here so that the actual force is reduced because of this diagonal member contribution. And also interior column as well. You see that some tension forces, which we don't want this load combination. This is not realistic. We don't want it. So this model, you need to carefully go over. This is heart of structural tall building analysis skill and design. It's because it's not just only just the ETAPS learning. I keep uh, um, remind you guys what I'm teaching is structural engineering, not ETAPS. So you need to understand this fundamental compatibility. This is just the mechanics and compatibility issue because the finite element software is method, modeling method is basically depends on how you create. Sometimes, most of cases, one model cannot reflect all in reality. So you need to utilize a couple of version to ignore or avoid any non-realistic load paths. So this is the load we don't want to have this for your column final column design, right? Instead, these dead load cases, we switch to this order sequence dead load. Okay, so this order sequence dead load is we have a set every two floor construction, so every building is constructed, self-rate induced column actual force is increased, right? It's common sense. So when you build it, self-weight is increased gradually. So that load cases, after that, we add this diagonal member. So that means we are constructing that entire building and without final connection of these diagonal members, once we build entire building up to the top out, then we come back and permanently we make this diagonal connection so that this is actual forces in the diagonal member will not generated until the building is top out and final connection is completed, right? So, but after that, obviously superimposed dead load and live load due to the dead and live load will occur because after building is constructed, you'll experience the live load with this diagonal member. So obviously you may some uh, consider this is a load distribution due to the dead load due to the live load. But when you combine entire load combination for final strength design, you see right? All this forces. Yes, still we have some issue. Download was composed download and live road. Okay, live road is pretty significant. All right, so still we have some issue here. So this is what I think has some limitation of this model. So we need to First, we need to go back to that the previous model without diagonal, right? Without diagonal, and you design the column based upon all gravity load, and then come back with the diagonal. Then we need to adjust the column, right? With the column type with our legal trusses, we have to adjust the column as we did because of that. This column is contributed as part of lateral load, so column size increased, and you need to confirm that all the sizes uh, will work for gravity and lateral. Since we have a relatively heavy live rod, you still experience some. What what do you use? Live rod? Okay, 70. And load combination is 2. Yeah, dead load, we using auto sequence dead load. Live rod is 1.6. Compose dead load. Okay. So there are a few exercise we need to fully aware of it. So before you design any members, you need to better make sure that your loading is makes sense and realistic. So I think somehow based upon that 1.2, that 1.6 live, still you see that you have this condition. 980 goes down 340. So they'll wait a minute. No, it's fine. Oh, okay. This is actual minimum maximum. Okay, minimum maximum. Okay, so mm, one thing maybe I need to turn off that. Okay, let me go pause. All right, so let's go through the previous download since this cases with analysis based with this diagonal. So diagonals pick up this the column node, right? So there will be some tension minus plus tension, which we don't want it. So this del load is replaced. We're gonna use auto sequence del load. So let's see, the 20, yeah, 20 at the building is top out. So every column is compression, right? So this is the load combination, auto sequence del load. We're gonna use it. And but the live load is everything's tied together. So we may have you may think we're gonna experience some of this condition that column, the building is experience the live load, which since diagonal is be in place, we'll have experienced this. So I think when you look at this, um, the ETABS give you kind of both negative and negative and maximum. I think in this cases anyway, this negative the governing. But we have some situations still there. We need to carefully review it. So obviously, column below is governed by also lateral gravity and lateral effect. So you have envelope the maximum compression and tension. So we need to include all the effect and carefully, especially this outrigger system, we need to consider all the cases scenario and use the maximum unfavorable compression and tension forces for finalizing the design. All right. All right. I hope this is gonna a pretty long video, but I want you to just take a step one at a time and eventually change this diagonal and set it up the load combinations with the order sequence that load. Just take a look at one at a time. Okay. And if you need it, we'll maybe meet together on Tuesday morning, right?